All right, so today we're going to look at lesson 4.4. You can see from our to-do list here going on, but I'm just doing the lesson itself here, and it's relatively short. We're going to look at trig functions of any angle. So even though maybe it's not something from the unit circle, or maybe it's not something that we know much about, we can reference other angles that we do know in an effort to find out about what we call reference angles. And a reference angle is always an acute angle formed by the terminal side and the horizontal axis. All right, so an acute angle, meaning that it's less than 90, and means that you're going to always use your horizontal axis and wherever that angle lands. So maybe the angle looks something like this. It's like out here, and maybe it's a quadrant 2 angle, so maybe it's like right there. So this is your angle. The reference angle would be the angle, it's an acute angle that's formed with the x-axis and the terminal side. So here is the terminal side, and here is the x-axis. So it's, and all the values of that acute angle would be the same, because if you can imagine the reflection that would happen, that angle is actually the same as the one that's over here if theta was over there. So the sine, the cosine, the tangent, all of those values are going to be the same because ultimately those are the same triangle. So we're going to look at it as though it was over here in the first quadrant and was acute, even though in the second quadrant. Now, it has the same values as that quadrant 1 angle, but because you're in a different quadrant, it might still have like negatives. And so we'll have to adapt and change the sign based on what quadrant we're in. All right, so let's look at if you had an angle that landed in the third quadrant. All right, so here's what it would look like, something like this, and it goes all the way around there. But rather than using that big angle, we're going to use its reference angle, which is the acute angle formed with the x-axis. So right here is going to be the angle that we deal with. And it would have all the same values as that big second or third quadrant angle. Lines might be different. All right, last one. If you had a fourth quadrant, so now we're getting kind of big angle here. It's going to wrap all the way around. It's going to go around, clear around. I don't know. I'm going to make it look like it's down here this time. All right, so that huge angle right there actually has all the same values as the acute angle formed with the x-axis. So right there is going to be my theta. And I just have to know that it's in the fourth quadrant. So I'm moving right, which would be positive, but I'm going down, so sine would. When you're looking for the reference angle, now these could be angles that we do know on the unit circle, but they could just as easily be things that we don't know. We just have to understand what that acute angle would be. So it has everything to do with the symmetry on our unit circle. We know 300 degrees is down here. So the reference angle would be the angle created with the x-axis, so it's right here. So if the original angle went all the way around to 300, what would be left over here? What's the reference angle going to be? And ideally, you can tell that that would have to be a 60-degree angle. Now, it varies on what you would do depending on what quadrant you're in. So I usually just draw the picture and it comes out pretty easy that way. All right, so let's look at this one. What if I gave it to you in radians and just for the fun of it also made it negative? So I have a negative 3 pi over 4. So I know that a 3 pi over 4 normally would be over to here. But it's negative, so I'm going to back up that much. And so it's like this angle right here. That's what the angle is. But that is not an acute angle. So to do the acute angle, I'm going to go to the x-axis right here. It would be this one right here. All right, and if you can imagine that we just went back right here was negative 3 pi over 4, what's going to be left to finish out that? And since that's a unit circle problem, ideally you can tell, oh, that'd just be a pi over 4 is what's left, 45 degrees. But since it's in radians, I have to answer back in radians, and that would be pi over 4. All right, now let's get crazy. Let's do radians. I know it's radians because there's not a degree symbol, but it's not something in terms of pi. So we're going back to day one with our activity and the string wrapping around. How many radians? Well, not how many radians. I know it's 2.3 radians, but where do you think that angle would fall? How big of an angle is a 2.3 radian? All right. Hopefully you remember the string. The string is going to wrap around here. There's 1 radian. And then you're going to do it again. There's 2 radians. And then a 0.3 radians. So somewhere up here in this second quadrant is what I would have. Do you remember how many radians it is all the way to the end? It's pi radians all the way to the end. So to find this reference angle, terminal side and the x-axis, to find this, all I would do is I would take the full all the way, the semicircle, which is pi, and I would subtract the blue part that I went all the way around. So if I could take the pi, subtract out the 2.3, and what I'm going to have left then is the angle I want. So I'm going to do pi minus 2.3. Put her here. And I'm going to be accurate, I guess, to 2 decimal places, I guess is fine. So I'm going to go with 0.84. Now, if you like to write radians, you can go ahead and do that. But we always assume it's in radians if it doesn't have the degree symbol. Now, here's the situation why we are doing reference angles, because not everything ends up in the first quadrant, but we can imagine the triangle that would be in the first quadrant. So here I have a point. I have a negative 5, 6, and that is a point on the terminal side of theta. So negative 5, 6 is somewhere up here, let's say. And if that's on the terminal side, my angle is this one right here. But to be able to find the sine, cosine, and tangent, I need to create the acute, well, really I need to create the right triangle that is formed, but I can't do a right triangle with what's going on. That's not a right triangle. We're not going to do that. Undo that. Don't do that. We don't want that. What we want is the reference triangle. And so, yes, I'm still going to use this, but now I'm going to use the x-axis with it. So this is my reference angle, which is going to have all the same values of that blue original angle, but since it's in the second quadrant, I'm going to change some signs. All right, so here we go. Now, if I'm supposed to find the sine, cosine, and tangent of that angle, I need to know what the side measurements are. Could you tell me what a couple of side measurements are? Since we went left 5 and up 6, this actually would be a negative 5, and this would be 6. It's important that you put the negative on there. That's what's going to keep our signs accurate. Now, to find the hypotenuse, I'm going to have to do a little Pythagorean theorem. So I know that's going to be a 25 plus 36 equals c squared. Now, we are going to keep these exact. And so I'm going to go ahead and leave that. Well, I don't even need the squared. C squared is 61, so c is the square root of 61. So this hypotenuse is the square root of 61. If it reduces, you must reduce it. 61 does not reduce. All right, so now I'm going to do the sine, cosine, and tangent of this reference angle down here. So looking at sine, Sine is opposite over hypotenuse, so that's 6 over the square root of 61. But we would want to rationalize that. Some of you might be able to rationalize in your head. That'd be great. That'll save you a little bit of work. So there's my answer. That's the sine value. Now let's try the cosine. Cosine of this angle is going to be adjacent over hypotenuse. So that means I'm going to have -5 over the square root of 61. Then when I rationalize, I end up with -5 root 61 over 61 for the cosine value. All right, last one is tangent. The tangent of theta would be opposite over adjacent. So that's a quick, easy one. That's 6 over -5. And no reducing that happens, so I'm done right there. There's the tangent value. Now, what I'm finding here are all the values of the original angle, the big angle. But by using my little reference triangle, that's how I'm able to find those values. But I've also made the appropriate signs negative, which is going to keep track of the fact that the original was actually in the second quadrant. All right, last slide here. I told you, it's a quick lesson. All right, so we're going to do the exact same thing, but the information is going to be given to us differently. Given that cosine of theta is -3/7 and sine of theta is less than 0, find the missing trig values. Well, I have to be able to draw this like I was previously, but I have to figure out where to draw it. And so it tells me that cosine is -3/7. If cosine is going to be negative, it's going to have to be in one of these two quadrants. Now, which one? Well, that's the reason they're telling me this. Sine is less than 0. Okay, so if the sine of theta is less than 0, that means it's going to be negative. So will sine be negative in this quadrant or this one? Oh, down here in this one. Okay, so I'm going to draw it down in the third quadrant. Remember, when you draw it, you always draw out of the origin, and then you always drop straight back to your x-axis to create this nice right triangle going on here. Now, theta is going to be in here. That's going to be my reference angle. That's going to have all the same values of the big angle, only that it's third quadrant, so the signs are going to change. Now, cosine, they tell me, is -3/7. And cosine is going to be the adjacent over the hypotenuse. So that's a 3 and a 7. But one of them has to be negative. Don't make them both negative. That would end up making it positive. And in fact, your hypotenuse, this is important when you're drawing these, the hypotenuse will always be positive. So the negatives will always have to go on the opposite or the adjacent. In this case, I went left 3, so that's where my negative is going to go, is on that 3. And then I'm going to do a Pythagorean theorem to figure out what the other side is. So they'll give us enough information for two sides, then we're going to go do Pythagorean theorem. So it's going to be 9 plus b squared equals 49. So b squared is equal to 40, square root both sides, so b is going to be 2 root 10, and that's going to be right here. But you need to realize, and this is why I draw the picture, to help me realize that that leg is going down. So not only 2 root 10, it's actually going to have to be a -2 root 10. The picture should help you get your signs accurate. Once you have all three sides, then you can start finding all the other missing trig values. They've given us cosine, so I left that spot blank, but now we're going to do sine. Sine is going to be opposite over hypotenuse. So -2 root 10 over 7. That does not reduce, so I'm good to go. Now, once you know sine, you can immediately find cosecant, because all you're going to do is flip it. So it's a 7 over -2 root 10. but we do need to rationalize. When you rationalize, only worry about the radical part. Just leave the 2 alone. So you're going to have a 7 root 10 over root 10 times root 10 is just 10 times the negative 2 is negative 20. All right, so next comes this row. They already told me cosine. I don't have to find it, but I am going to look at the cosine to figure out what secant is, because secant is the reciprocal of that. So it's just going to be a negative 7 over 3. All right, last set is tangent. When you're looking at your triangle, tangent of theta is opposite over, opposite over adjacent. So that's going to be a negative 2 root 10 over 3. Doesn't reduce, so I'm done. But the cotangent is the reciprocal of that. So then I'm going to flip it. It's going to be 3 over negative 2 root 10. And then I'm going to rationalize. And I'm left with a negative 3 root 10 over, and remember this right here is just 10 times the negative 2. That's a negative 20. That's all that can happen there. Actually, let me fix that. I put that negative on the 20, but I really had already acknowledged it by putting a negative out in front. So don't put 2 negatives there. So that does not reduce. I'm good to go. All right, so really kind of all we're doing is talking reference angles today, drawing those triangles so that you can make a right triangle. It is important that you make it a right triangle, so I'm going to go over that one last time before I turn you loose. When they give you the information, you're going to figure out what quadrant, and then you're always going to come from the origin out, and then you drop perpendicular back to the x-axis, and that's how we get this right angle here every time. And then your other side is going to be along the x-axis. All right, that's all I've got for you. Good luck.